Let me share my screen real quick for you guys. All right, guys, today I'm going to review with you Module 4 Written Exam Zoom Report. Let's go on to number 1. So in question 1, our goal is to write 4 sets of fractions with 3 fractions in it. First, let's start with the hexagon as the base denominator. A way I made this easier to understand is, for example, how many trapezoids would it take to make one full hexagon? So part A, I do want to start with the hexagons as our base denominator, so let's go ahead and do that real quick. There's one hexagon. How many rhombi is it going to take to make one full hexagon? Well, there's one rhombi, there's 2, there's a half, and there's another half. So 1 and 1 and 2 halves will equal 3. So 3 rhombi for every one hexagon. So that is 3. Let's see the trapezoids. There's 1 and 2. 2 trapezoids for every one hexagon. That is 2. There's a hexagon. How many triangles is it going to take to fill up the hexagon? There's 1, 2, 3, 4, 5, and 6. 6 triangles for every one hexagon. That is 6. Let's use the trapezoid for our base now. So how many rhombi is going to take, or how many hexagons will it take? I apologize. Well, we know that a trapezoid is already half of a hexagon. So we know that for every one hexagon, there are 2 trapezoids. That is half. Now with the triangles, for 3 triangles, it makes 1 trapezoid. So that is 3. How many rhombi will it take? There's 1, and then there's half. So 1.5 rhombi for every 1 trapezoid. How many? We're going to use the triangle for the base. So this is a little bit more confusing because the triangles are so small. So for every 1 hexagon, there's 6 triangles. That's 1/6. And for every 1 trapezoid, there are 3 triangles. So that is 1/3. For every 1 rhombus, there are 2 triangles. So that is half. Let's move on to the rhombus. For every 2 triangles, there's 1 rhombus. So that is 2. For every 1 trapezoid, there's 1.5 rhombi. So that's 1.5. For every 1 hexagon, there are 3 rhombi. So that is 1/3. All right, so let's move on to number 2. It's our homework number 11. Number 2 has a few steps to get to the final answer. Step 1, you need to add a mark on the remaining portion of the rope to designate the amount used to tie up the carpet. This will show you the new amount of rope. Step 2, now split the remaining rope into equally sized portions. Note that the length of each portion should be the same length of the rope used to tie up the carpet. So 3 parts of the rope represent the 36. So right here I have marked what was used for tying up the carpet. Then I had to split this into 3 equal sections. And our leftover we already know is 36. Well, 36 divided by 3 is 12. So that means each little section here is 12 foot. Well, then we need to split up the rope into all equal pieces to figure out the original amount of the rope. So we already have the 3 12-foots. Well, now we need the other 3 12-foots over here. So 12 times 6 is 72. So 72 foot of rope was originally bought. So on number 3, there's 4 different parts of the question. Our goal is to represent the equations that we were given with fraction strips and number lines. The fraction strips are very similar to the fraction circle diagrams that we're going to be using in number 4. We should be familiar with the number lines already and the fraction strips. If you're not, then you need to refer back to the problems in Module 4, homework 17 through 21. So here we're doing 1/3 plus 1/2, and it equals 5/6. And here's our fraction strip to represent that, and here's our number line to represent that. Part B, 1/2 plus 3/4 equals 5/4, which simplifies to 1 1/4. Well, here's our fraction strip to represent that, and here's our number line to represent that. C, 3/4 minus 1/3 equals 5/12. Here's our fraction strip. Here's our number line to represent that. Moving on to D, 3/4 minus 3/6 equals 1/4. Well, now we have right here how we represent that with a fraction strip and how we represent it with the number line down here. So what is 3 times 1/5? We're going to be using the circle diagram. So we're going to be splitting the circles into fractions. Multiplication by a positive integer can be viewed as repeated addition. First, you need to determine how many fraction circles are needed or being added. Then you need to determine what the fraction circle needs to represent. So the way you can tell this is the number of fraction circles you need is right here, the positive integer. And then, of course, the fraction here is what your fraction circle needs to represent. So let's do 3 fraction circles of 1/5. 1, 2, 3, and that is your answer. It's going to be 3/5. Moving on, 3 times 2/4. So we need 3 of the 2/4. 1, 2, 3. So that equals a whole, and then 2/4, which is a half. So 6/4, which simplifies to 1 1/2. Now we need 5 of the 5/8. 1, 2, 3, 4, 5. 1, 2, 3. So now we have 3 1/8. So 5/8 simplifies to 3 1/8. Number 5 provides you with a square that's cut into different shapes, triangles and rhombi of different sizes. There are 7 pieces, guys, that we need to determine the fraction of the area that is being taken up by each piece. So we need to consider the whole as the square. So what fraction of the area of the square is A taking up? Well, A is taking up 1/4. It will take 4 of these triangles right here to cover up the rest of the square. We do the same with the rest of the shapes. Area of B is 1/4 as well. Same shape. Area of C is 1/16. Area of D is 1/8. Area of E is 1/16. Area of F is 1/8. Area of G is 1/8. So number 6 provides you with a recipe for chocolate brownies. The recipe will make 16 brownies, but you only want to make 12. Well, you would need to figure out what fraction you would multiply 16 by to give you 12. Then you would multiply all the ingredients in the recipe by said fraction. So 12 divided by 16 is 0.75, which is actually equal to 3/4. So you need 3/4 of the recipe. So 1/3 times 3/4 equals 1/4 cups of butter. 3 times 3/4 equals 9/4, which simplifies to 2 1/4 ounces of unsweetened chocolate. 3/4 times 3/4 equals 9/16 cups of sugar. 1 1/2 times 3/4 equals 3/8 teaspoons of vanilla. 2 times 3/4 equals 3/2 eggs. 2/3 times 3/4 equals 1/2 cups of flour. And that is my Module 4 written exam. Thank you.